2.5 miles beneath the surface of the North Atlantic, the pressure is strong enough to crush a titanium sphere like an aluminum can. Down here, nothing is supposed to move, nothing is supposed to grow, and nothing is supposed to change. For more than a century, scientists believed the Titanic was frozen in time, a steel monument preserved in the silent darkness of the abyss. But during a recent deep-sea expedition, researchers detected something inside the wreck that shouldn't exist, a rhythmic signal coming from deep within the ship, and whatever is causing it is changing the Titanic faster than anyone ever thought possible. For decades, the prevailing wisdom was simple. The Titanic was a frozen monument, a steel corpse preserved by near-freezing temperatures and the absolute stillness of the deep ocean. But the latest descent by a specialized expedition team has revealed something far more unsettling, a biological and structural reality that contradicts everything we thought we understood about deep-sea preservation. The ship is not simply decaying. In the way scientists predicted, it appears to be reorganizing, slowly, methodically, under the influence of a force no one anticipated. During a high-resolution mapping mission in late 2024, expedition teams detected something strange within the stern section of the wreck. For decades, this area had been considered nothing more than a chaotic debris field, but the new scans told a different story. Sensitive acoustic sensors began detecting a localized rhythmic resonance coming from deep within the hull. At the same time, researchers noticed something even stranger: massive structural pillars. Supports that should have remained intact for at least another 50 years had simply vanished. This was not the slow fading of steel into silt. It was something faster, something more aggressive, an accelerated consumption that suggests the environment, 12,000 feet below the Atlantic, is far more volatile than we ever imagined. The discovery was led by a consortium of deep-sea archaeologists using a new generation of autonomous underwater vehicles. These drones carried LiDAR systems capable of scanning through dense, sediment-filled water with millimeter precision. As the data streamed back to the research vessel above, the team noticed something disturbing. The famous silhouette of the Titanic's bow no longer matched previous surveys. Part of the promenade deck, once the height of Edwardian elegance, had completely disappeared. In its place was a hollowed-out geometry of twisted steel. But the missing structure wasn't the most alarming detail. It was the edges. They were not jagged, like metal torn apart by structural collapse. They were smooth, unnaturally smooth, as if the steel had been dissolved from the inside out. Further measurements revealed something even more concerning. The deterioration rate of the ship's steel is now far exceeding the known activity of Halomonas titanici, the iron-eating bacteria first discovered on the wreck. Sonar telemetry suggests the hull has reached a structural tipping point. In several key areas, the steel has thinned to only a fraction of its original thickness, almost as if the ship is slowly being hollowed out. But the most unsettling discovery was thermal. Sensors recorded water temperatures surrounding the hull, several degrees warmer than the surrounding deep ocean. In an environment where temperatures barely change, this kind of thermal anomaly is extremely unusual. It suggests that something inside the wreck is generating heat, an ongoing chemical reaction, deep within the ship. And every few minutes, the immense weight of the ocean above shifts slightly, as the internal structure of the Titanic groans under the pressure. Sounds that were rarely recorded in earlier decades are now appearing constantly in the expedition's acoustic logs when the submersibles entered the massive opening. Where the grand staircase once stood, they descended beyond the upper decks, into the lower cargo holds. These areas had long been inaccessible, buried beneath tons of collapsed debris. But this time, the cameras captured something. That caused Mission Control to freeze the live feed, a dense, gelatinous colony. Coated parts of the ship's electrical switchboards. The mass emitted a faint bioluminescent glow, and it pulsed, slowly, rhythmically, in perfect synchronization with the acoustic signal detected earlier. This was not ordinary mold, not fungus. It appeared to be a coordinated biological structure, processing the heavy metals and rare earth elements found in the ship's wiring. But the most disturbing discovery came seconds later. The ROV's navigation system suddenly began to malfunction, Compasses drifted. Stabilization systems struggled to correct. Sensors eventually traced the cause to a localized magnetic anomaly centered in a single section of the cargo hold. The magnetic variance was strong enough to interfere with the vehicle's instruments, which suggests that something inside the Titanic's original cargo may be interacting with pressure, salt water, and time in ways maritime chemistry cannot yet explain. Scientists are currently debating 3 possible explanations. The first is the most conservative: a biological perfect storm. Changes in deep-sea currents may have delivered an unusually rich supply of nutrients directly into the wreck, supercharging microbial activity into something far more aggressive than previously observed. A second theory suggests that the Titanic may have carried unrecorded industrial materials, heavy minerals, experimental alloys, substances that, after more than a century underwater, are now entering a volatile phase of decomposition. But there is a third possibility, one that some researchers are hesitant to discuss publicly: that the wreck has become a catalyst for an entirely new deep-sea ecosystem, a massive colony using the ship's iron as the skeletal framework for something biological and perhaps partially synthetic. Each theory explains part of the data, but none of them fully explain the heat or the rhythm. Despite the enormous scientific importance of these findings, the expedition has encountered resistance. Several hours of sonar recordings and thermal mapping data have not been released to the public. Officially, they are considered proprietary research by the corporations funding the mission. This has created tension between marine archaeologists, who see the Titanic as a protected historical site, and private entities interested in recovering artifacts before the structure collapses completely. Plans for a follow-up expedition have already been delayed. Some insiders suggest political pressure and complex international maritime laws are slowing further investigation, especially concerning the magnetic anomaly, which raises an uncomfortable question: who truly owns the secrets lying at the bottom of the ocean, and what might we discover if we look too closely? For most of us, the Titanic is a frozen moment in history, a grave in the deep ocean, a relic of 1912. But the newest discoveries suggest something very different. The ship may have entered an entirely new phase of existence, one that has nothing to do with the people who built it or the tragedy that sank it. Instead, the Titanic may now belong to the deep ocean itself, which raises a haunting thought. What happens when the greatest achievements of human civilization are reclaimed by environments we barely understand? Because the ocean does not simply destroy, it transforms, it integrates. And perhaps the greatest mystery of the Titanic is no longer how it sank, but what it is becoming in the dark.